to simplify fractions. You don't have to write this, but our standard today is I can simplify fractions with variables, and write equivalent fractions. Our first vocabulary word is just to simplify. What does that mean? It's when the only common factor of both the numerator and the denominator, the top and the bottom, is just 1. So when 1 can go into that. So just doing a quick review, simplify both of these fractions. So what can go into 28 and 44? Well, 4 can. 4 can go into 28 7 times. 4 can go into 44 11 times. Remember, if you don't know what the greatest common factor, in this case it was 4 that went into both of them, you could always start dividing by 2 and just keep dividing by 2 till you get it if they're even, or 3, or 5, or 7. In this case, if I divide by 2, I'd have 21 over 6. Well, 2 can't go into both of these, but 3 can. 3 can go in here 7 times, 3 can go into 6 twice. You do not have to switch this back to a mixed number unless it's dealing with word problems. So let's do a negative. It works the same way. As long as only one of them are negative, it stays negative. So what can go into 9 that goes into 45? 9 can. Goes in 1 time with 5 left, and then 9 goes into 45 5 times. And because it's just one negative, it's just a negative 1/5. How this is used in real life. The school bus holds 150 students. Mrs. Monroe's class is going on a field trip. There are 35 people going on the field trip. In simplest form, what fraction of the bus was full? Go ahead and write a fraction. Well, since the bus holds 150 kids, that's your total, so that's your bottom. There are 35 people going on the trip, so now we just need to simplify that. Well, 5 goes into both of them, 7 and 30. So what is the fraction of the bus full? 7/30. So where is this going? We can simplify with variables the same way we simplify with numbers. In this case, if we simplify this fraction, 12/30, 6 would go into both. So 6 goes into the top by 2, and 6 goes into the 30 5 times. Let's go back and see if we remember what prime factorization is. Hopefully you remember you're making trees. Now, if you don't have to make the trees if you remember, or you can do it in your head, but let's just look. If I take 12 and make a tree, I would get 2 and 6, 3 and 2. Go ahead and do a tree for 30. I would end up with 3 and 10, 2 and 5. So if you do this out, on the top you'd have 2 times 2 times 3, and on the bottom you would have 2 times 3 times 5. So think about that. If you simplify fractions using prime factorization or the product of the primes, well, 2 divided by 2 is 1, so they would cancel out. 3 divided by 3 is 1, so they'd cancel out. So you're just left with 2/5, which is exactly what you have here. So let's think of this when we start adding letters. So this first example, 6 over x, or 6x squared over 4. So if you can simplify the numbers, just do it the easier way. 6 and 4, well, that would be 3, and the 4 would simplify to 2, because 2 would go into both of them. And in this case, there's nothing to simplify with the x because there's only on the top. It's when there's some variables on the top and some variables on the bottom, like this one. So in this case, we first look at the numbers. Let's simplify that. What can go into 28 that could also go into 42? 7 can. So that would simplify to 4/6. Uh-oh, that could go again. So let's put that down to 2/3. Now let's look at our n's. N to the third power really means n times n times n all over, and that's one of the n's. So now when I go to simplify, n divided by n cancels out. So what I'm left with is 2 on the top. I have 1, 2 n's, or n squared, all over 3, because that n has gone away. Stop the video now and try this next one all on your own. All right, so let's look. I'm going to write them all out. A to the fourth means A times A times A times A times B times C times C times C, all over A. B squared means I have 2 B's, and C squared means I have 2 C's. So now we can start canceling them out. Well, this A and this A cancel out. There's no more A's, so I'm left with 1, 2, 3 A's on the top, which would be A to the third power. Let's cancel out the B's now. There's 1 B here, and there's 1 B here, so that just leaves a B on the bottom. And now let's do our C's. 1 here and 1 here, so that cancels out. 1 here and 1 here, so I'm left with just a C on the top. So my answer is A to the 3, C, all over B. See if you can start noticing what's happening here. If you look, do you see how I had A to the fourth and an A? Well, since there were 4 on the top and 1 on the bottom, I can just subtract, and I got A to the 3. If you look at your B's, and if you don't understand this trick, don't use it. Just put them all the way out. But you have 1 B on the top and 2 B's on the bottom. So there's more B's on the bottom by 1. 2 minus 1 is 1, so the 1 goes here. In this case, the C's, you have more C's on top, so there's going to be up on top, and you have 1 C left. 3 minus 2 is 1. Go ahead and try your homework.